So we're starting with our next talk. Sometimes it takes a crisis to give an opportunity to great people to show their proficiency and how good they really are. And one apparently big crisis in Switzerland or in the world has been the corona pandemic. And suddenly people popped up and said, hey, we know how to deal with this from our perspective. So we have something to contribute. And one person who was able to contribute was Carmela Troncoso, assistant professor from the APFL in Lausanne. And she co-designed and co-led the project that gave us the tracing app. The tracing app was technically a huge success. It was probably not that huge success with the users, with citizens, people living in Switzerland, but that was not the problem of the technology, because the technology was great, and Carmela is a great person, and she's a great scientist, and I was very happy to work with her on a different conference, and then being able to invite her here to present her ideas on privacy engineering at Swiss Cyberstorm. Please welcome Carmela Troncoso.
Thank you, Christian. Hello, everyone. Hello, dark things in the light. Okay. So yeah, I'm going to talk a little bit about my experience with privacy engineering and what I have learned about how to do it in the 10, 15 years I have been working with it. And privacy engineering, in a way, started kind of being a thing around 10, 15 years ago when we started to have the idea that we need privacy on digital services, right? People started to see how services were taking too much data, were profiling people, were doing things that we were not very comfortable with because it seemed like an invasion. And we saw a lot of these, we need privacy, privacy by design, come on, let's just engineer privacy. But I believe here that I'm in a room full of technologists, and if you ever kind of had to do this thing or somebody told you, you probably felt a little bit like this, right? Privacy engineering is a paradigmatic example of draw the freaking all kind of thing, where people tell you, do something, but do not tell you how to do it. So in my research, I spend a lot of time thinking, like, how do we engineer privacy? I come from academia, where we have a lot of publications and papers, where we build these amazing systems that can do extremely cool things with a lot of privacy into them. But how do we explain this to, for instance, my students at EPFL? How do I tell them how to think as a privacy engineer? And the first thing that comes to mind when you talk about engineering privacy is the idea that we should not have data, right? Privacy is this thing where people don't have your data, which is associated to the data minimization principle in the regulation. And the idea is that the less data that is in the system, the more privacy preserving the system is. And this is kind of course, correct. It's a good idea. It's very intuitive. But what actually happens is when you're going to engineer a system and you think from this perspective, it doesn't really kind of work exactly because it's not really data that is minimized in a privacy-preserving design. Typically, the kind of tricks we use is to process data in a local device, is to maybe split the data and distribute it in 2 servers. Maybe we encrypt the data and use advanced cryptography to do operations in the encrypted domain. But at the end of the day, the data is there. The data is in the system. So it's not really something that people can use to kind of map the idea of privacy engineering to how to build. Also, when I talk about data minimization, I am not talking about the use of the data. I'm saying collect as little data as possible, but not really about how many things you can do with this data, and in which shapes you could collect the data, and the different purposes that that would entail. And what this leads us to think is that data minimization on its own is actually a bad metaphor to tell people about how to do privacy engineering. So we went back to the drawing board. It's like, it doesn't work. Why it doesn't work when it is so intuitive? It is about eliminating data. And the thing really, like after a lot of years, I realized that when we build systems, really privacy at the end is not the goal. And even if you think about your common lives, privacy that you want to have it is never kind of the goal. You don't want to have privacy for the sake of not telling people my things. In general, you want to do this because you want to protect yourself from influence, from intervention, from manipulation, from coercion, because we know when other people have data about us, they can start feeding us information in a particular way. We have a lot of this nowadays with all of this fake news. Think about, for instance, one of the most famous cases, the Facebook Cambridge Analytica scandal. It was really, yeah, it was a privacy problem, but it was a problem. It was not that the data was taken by Cambridge Analytica, it's how they use it to influence people. And if we could put a privacy technology in place that would actually have allowed Cambridge Analytica to collect and create models in a privacy-preserving way, we would not be happy with it, probably, because Cambridge Analytica could still manipulate people with information that they have learned in a privacy-preserving way. So it's not really that privacy is the goal, right? It's actually what we need to keep our freedom. Sorry about the mess with the animations. So actually, when we think about, from a privacy perspective, when we think about this goal of protecting our freedom, of protecting ourselves from interventions, the kind of the holy grail of the system we would like to build is one, if we don't need to trust the system, not because they don't have data, but because they cannot misbehave, because they cannot use whatever we give the system to actually intervene with our freedom. And in this sense, purpose limitation, which is another data protection regulation principle, is actually a very good metaphor that kind of leads what you want to do when you do a privacy-preserving design. You want to create a system that, via privacy, eliminates the capability of the system to harm, to do any damage, by minimizing the purpose to exactly the only thing that you would like the system to do. And that does not mean that data minimization doesn't have a role. It's actually very important, because if we don't minimize the data, it is very hard to actually minimize the purpose, because you have more data, then you can do more and more things. So we need to think from a data minimization perspective, but also go a step beyond and look at purpose limitation. And the kind of strategies that, in general, privacy engineers can use to minimize this purpose that the system can have is, of course, minimize the collection and disclosure of data. That is natural. But you should also try to minimize linkability. If you have some data, that you cannot put it together, because then you have more data that maybe can be used for other purpose. Minimize centralization. You don't want all the data in one place, because then that party becomes very powerful. And as I said, maybe if there is some privacy-preserving technology involved, still they have the power to influence and manipulate you. We want to minimize replication so that we don't have to solve this problem in many places, minimize retention, like those are natural things. So that is kind of how I perceive the process of embedding privacy in the engineer of a design, trying to limit the kind of purposes that it can do. But the name of the conference, or the theme of the conference, was digital identities. So kind of, I guess that now you're waiting for me to tell you how to do privacy engineering of digital identities. And I'm sorry, but I'm not going to exactly do that, because that's very hard. And it is very hard because digital identities are, in most forms, linkable, right? And then what happens is that the digital traces that I create with my digital identities, they can link to each other. Then I create a profile, and then it's very hard to limit the purpose, because once you start having pieces of data and putting them together and building something bigger, I cannot anymore limit the purpose by limiting the purpose of the individual pieces of data, because you just create more knowledge than what I had before. So actually, to do privacy engineering, we need to maybe step away a little bit of the digital identities and kind of the way that we think nowadays to do systems. Like the usual approach when we want to build a digital alternative for a process is that we take the offline solutions and we try to digitalize it, step by step. An example that we heard before, for instance, was the Mes Vaccins system, in which you have exactly the same system, but in a digital way. You digitalize the card. Right? And that happens to, in general, be a way to building systems in which you create a lot of data, because on the offline world, creating that much data is not so important. It's very hard to link each other. It's very hard to analyze. Like, this becomes very problematic when we move to the digital realm, when we can throw all of the digital data mining to it. And then what tends to happen is that there comes some regulatory compliance, like particular data protection, and you end up collecting a little bit less and have a system that is a bit more limited than the one you envisioned in the beginning. But when you think as a privacy engineering, actually you think the other way around. you start thinking about what is the purpose? What is the purpose of the system I want to build? And what could be the minimal system that would allow me to do this purpose? And then it may be that for operational purposes, like to prevent some security threats, or maybe to deal with some other regulation that requires some accountability, you need to maybe build a little bit bigger system. But what happened in this case is that the system that we have here at the bottom is always going to have, in general, less data and less purposes than the system that we build when we start by everything and kind of cut. And the truth is that once we're building this system, it may be that the purpose may not require an identity. And let me give you now 3 examples. These are real examples of things that my lab has created and actually either have been deployed or are on the way of being deployed. One was what Christian said before, the Swiss COVID app. And the Swiss COVID app, like when we were on the pandemic, we all know about this, the idea was to notify users of a potential infection. And when we started talking with epidemiologists about what this means, because I'm a computer scientist, what do I know about epidemiology? What we learned very quickly is that identities don't play a role. For epidemiologists, there are only 2 kinds of people: the ones that are not infected and the ones that are infected. Who infects you does not matter. If you get infection from only 1 person, or you get viral load from 2 different people, for them it's the same thing. There is viral load. So identities did not play a role. And it is because of this that we could build a solution in which we could use unlinkable Bluetooth random identifiers, Bluetooth beacons, to actually create a system in such a way that the data that was exchanged, the data that went to the server, the data that was accessible to anybody that is not the device itself, actually is useless for anything that is not strictly the purpose, which is to notify other people. The data that would be useful for other purposes, the data that would allow you to maybe know who has been in contact with whom, for how long, or where, all of that actually resides on the device of the user. And as such, the system itself cannot do any other thing that is not notifying people. Another example was a collaboration we had with International Consortium of Investigative Journalists. They came to ask us to build a search engine that would allow them to search into each other's documents, like the leaks that they have, in order to find documents of interest. And when they described this idea, it became really fast apparent that who has the document is not relevant for them. They want to find them. They don't want to know if A or B has it. And in fact, for them, identities are something that should be hidden from a digital perspective, right? From the point of view of digital traces, because it puts them at risk. I mean, maybe not in Switzerland, but in many other countries, you can think how actually even having a leak, even being interested on a topic, actually is a problem. Or you can think, as an example, about Snowden, right, that is living in Russia because he knew about a particular thing that he actually leaked. And then, of course, we don't need identities, but they wanted to know that the people participating in the system are actually members of the consortium, right? So they don't want anybody to be around sniffing on the leaks. And how do we create this thing? We used a cryptographic tool called attributes-based credentials, which allows you to prove in zero knowledge that you're a member of the organization. But you don't need to say which member. You just can prove with whole certainty that you actually were authorized by the consortium to use the system. And then other people can let you search on their collections without knowing who you are. And this way, the data that is in the system, the data that is in the central server, again, contains no risk, because even if that is hacked, even if that is leaked, there is no way of knowing which journalists have participated, when did they do, who was speaking with whom, and this way we can protect them and also protect the consortium, because there is no coercion, there is no seizing, there is no subpoena that would actually harm anybody in the system. And again, we didn't need identities. The last project is currently ongoing. We're working with the Red Cross to help them digitalize their aid distribution system, meaning when they go to a crisis area and then distribute goods that are needed. And the problem that they have there is that they have a limited amount of resources, so they want to make sure that they actually give the resources to the people that need them, and that these people cannot come and ask for 2 or 3 times so that they can distribute the resources fairly. And for them, it's actually not important who gets the resource, right? They want to know that this is a person in need and that they receive the correct amount, but it's not really important if it is Carmela or Christian. The only thing that they want to know is this is a person in need. The goal of the ICRC is to prevent harm, to help people, but not because of their names, just because they need help. And to build this system, again, we didn't use identities. We created a lot of infrastructure around that allows us to do privacy-preserving blacklisting and privacy-preserving auditing so that we can know if somebody's trying to come twice. We know in a blacklist that they cannot ask for help again. We can have a privacy-preserving audit in which we can check that the distribution actually gave all the resources to people that were in need, and they gave the correct amount of resources of each of them so that they cannot distill or do anything like this. And actually, ICRC wanted to use biometrics, because they thought that this was an interesting tool, an interesting digital tool. We found that there is a lot of problems, and in fact, the Red Cross has a policy that forbids them from creating a database of biometrics, because they know that if you have a database of biometrics, this puts in danger the people that you're aiming to help. You can think, for example, not so long ago when the Taliban took control of Afghanistan again, one of the things they did is to get the database of photos of refugees. And now those refugees have a big problem because they cannot change their faces, right? And so ICRC wants to avoid this thing. And then we complemented all of the cryptography that we sent, which decentralized biometric-based authentication in the sense that beneficiaries use biometrics to identify themselves to the distribution center, but in a way that there is no central database of biometrics. So again, the data in the system that we have, the system itself, only contains all of these privacy-preserving logs, privacy-preserving blacklists, in a way that when you look at them, you cannot know who got aid, when the aid was taken, how often, and in this way, we don't create digital traces that down the line may actually endanger the life of these refugees. So, okay, so far I have described 3 cases in which identities were not needed, in which upon analysis of the system, identities that look like something that, of course, we need to build a system like this because it is how we do it in the offline world, it was not needed in the digital world because we have a lot of cool crypto that we can throw at the system to build alternatives. But you may be thinking like, but what if identity is actually needed for the purpose? Which may happen, right? I'm not saying it doesn't. And then the first question that you should ask yourself is identity needed for the purpose? Or is it needed so that you can enable multiple purposes from the system? Which is a very legitimate thing to do, because sometimes to create something that you can monetize, it needs to do more than one thing, because otherwise, you don't have a product that you can really sell. And this is very fine. But the thing is, when you have a bunch of purposes, we're a little bit back in this linkability problem. When you create a system for purpose A that also can do purpose B, from the point of view of an adversary, the adversary also has A and B, and now they can also create anything that can be used by linking the data from A and from B. So even if you limit individually the purpose of different actions in the system, the overall purpose is going to be bigger. And the more purposes we need, the more and more difficult it is as a privacy engineer to actually limit the amount of things that you can do with this system. So doing multi-purpose privacy-preserving engineering, I'm sorry, is kind of close to impossible, because we cannot really do that. Like, the amount of data you're going to need, the amount of things you're going to have to enable are going to create a lot of problems down the line. And this does not mean that you should not build this system, that you cannot build this system. It just means that you cannot build it in a very strong privacy-preserving way, and you have to turn to policy mechanisms to actually protect the users, which may not have such a strong protection. Right? It is fine, it's just that you cannot really claim that the system is privacy-preserving by design. But okay, what if you only have one purpose and actually identity is needed for the purpose? The first thing I would do is ask you, really, are you 100% sure that this actually needed? And if not, just don't use identities, right? But if it is actually, then you can do 2 things. One of the problems of profiling is that because identity is linkable, you're going to link pieces of data that come every time we use your identity, and that's what creates a profile. So you can use privacy-enhancing technologies to maybe leave the identity but remove the data, doing things like private information retrieval, like private set intersection. Again, cryptographic primitives and cryptographic tools that allow us to do things without really knowing what data are we looking at. You can also create identities that, in a way, minimize the disclosure or the collection of data. Instead of doing something like when we have an ID that has my name, and that has my family name, and has my address, you can try to create minimalistic IDs. And that is very nice, and you can even use more cryptographic tools to have this thing. But then what I could ask you is then again, think again, if identity was really needed. Because if after doing step 2, you have actually thrown a bunch of crypto to minimize the disclosure, to create a minimal identity, and to maybe not disclose as much data as you would do in the beginning, maybe at the end, you didn't need to have an identity. You can just create a system with less data and with a less invasive way of interacting with the system. And you may also only discover this after actually doing the exercise of 2 and 3 and creating something super complex to, at the end of the day, not having used the identity. And with this, I want to end my maybe controversial talk to say that privacy engineering is not really about minimizing data. It's about minimizing trust in the system by minimizing the amount of purposes that the system can be used to, and that indeed means that you're going to have to minimize the amount of data that the system collects and the system processes. And we do this by identifying architectures, like decentralized architectures, and technologies. I name a few today. I'm sorry for the bus dropping, but I don't have the time to go and explain each of them. But there are plenty of those that allow us to build systems in a different way that actually don't allow for multi-purposing of systems. And digital identities are most of the time not necessary when you're actually thinking from a privacy-preserving way, from a privacy engineering perspective. And finally, the more purposes a system has, the harder it is to limit the purpose of the system, the harder it is to protect the users. So I'm sorry, like we have a lot of very cool privacy-preserving technologies, but still we cannot do miracles. So just to close and to go back to the theme of the conference, digital identities and how to secure them. If you ask me from a privacy engineering perspective, the best way to secure my digital identity is to not create it. Thank you so much.
Very good. Thank you very much, Carmela.